Okay, so we've got a couple more properties of logarithms. This particular property, the change of base formula, I'll tell you what, this is actually incredibly useful. And this says to approximate this. We're going to, these properties up here are actually for section 5.6, so I'm going to hold off on those. But let's use the property we just used, the product. And let's rewrite this as log base 3 of 4 times 3. Now this problem could be solved with a calculator. When it says round the answer to 4 decimal places, that means use a calculator. But I'm not going to. I'm actually going to just approximate getting very close. When I rewrite this as log base 3 of 4 times 3, I can split that as log base 3 of 4 plus log base 3 of 3. Now, why would I want to do that? Because do you see how this matches right here? Remember that this whole thing is equal to whatever the exponent is there. Well, what is that exponent? That's equal to 1. So log base 3 of 3 is equal to 1. Log base 3 of 4, 3 to the first power is 3. 3 to the second power is 9. So that's just a little bit bigger than 1. It's just a little bit bigger than 1. So this is approximately 2.2. Now that's not exact. It's not by any means an exact answer, but it gives me an idea that when I type into my calculator and I use log base 3 of 12, and the calculator gives me 2.26, I know it's that's probably right because I got an estimated answer. Now, let's talk about the change of base because that leads us directly to how we could put this in the calculator if we didn't have this estimated value. If our calculator did not have a change of base option, which most of them don't. Your telephones, your cell phones, I'm dating myself a little bit, making myself a little old there, but your cell phones don't have a change of base on the calculator. They only have common log and natural log. And so we're going to use this right here. We're going to recognize that this right here is going to help us use our cell phones or little cheap solar calculators to solve some problems. What you need to notice is that this is a base A. It's not a common log, it's not a natural log, it's base A. But we can convert that to the common log or to the natural log by simply putting the number in the numerator and the base in the basement. So I took log of M divided by log of A. And every calculator will do that. This would be natural log of M divided by the natural log of A. So let's take a look at how that looks in a problem here. I've got log base 5 of 89. If my calculator does not have a change of base button, like my cell phone, I would simply type this in as either log of 89 divided by log of 5. And that's in common log form. Or I could type in natural log of 89 divided by natural log of 5. Here's the interesting thing. Both of these will be the exact same answer. Let me show you on the calculator. I'm going to make my fraction, and I'm going to type in common log of 89, notice no base change, common log of 89 divided by common log of 5, and we get 2.788. Now I'm going to make a fraction, and I'm going to type in natural log of 89 divided by the natural log of 5. And it's the exact same answer. Now let me show you one time with the change of base. We use math, log base 5 of 89, and the answer is still 2.7889. Okay, so all three of these gave me the same answer, all three versions, the common log, the natural log, and the log base 5. So why is that useful? Once again, if all I have is my cell phone and I don't have a graphing calculator, I can still approximate this to 2.7889, and all of those answers will come out the same. So let's rewrite this one using a change of base. Let's use common log. I happen to like common log and natural log equally. It doesn't matter which one you use, so I'll do both. We're going to have common log, the square root of 5, divided by the common log of the square root of 2. Or we might rewrite that as the natural log of the square root of 5, the number goes in the numerator, divided by the natural log of the square root of 2. Either answer would be acceptable if I asked you to rewrite it. Then you would actually plug it into the calculator and come up with an approximate so that you could round it to 4 decimal places. So let's go back to this problem up here. Let's type in log of 12 divided by log of 3, or natural log of 12 divided by the natural log of 3. Now this is not equal to the natural log of 4. You cannot divide these numbers out. That's like saying that the square root of 12 divided by the square root of 3, well, actually, that's a little different. That's like saying the inverse cosine of 12 divided by the inverse cosine of 3 would be equal to the inverse cosine of 4, and it is not. You cannot divide your arguments out there, okay? And so I've got natural log of 12 divided by the natural log of 3, and we'll get 2.261, just what we got before. Approximately 2.2619, and now we have it to 4 decimal places. All right, good luck with section 5.5.